I'm at the Rivett lathe, and I'm just going to change over to the vertical milling attachment, the Traverse attachment, and I'll just show you how easy this is to swap over first. Comes off like that. Right, I've now swapped over, and immediately you'll be able to see, first of all, I haven't got the motor on the back here. I've just left that off just so that it's easier for you to see. I've increased riser blocks in here to make the overall height higher. I've increased the length of the threaded column, the threaded rod, and that's it running up, and it's quite free to run all the way to the top. And so that makes a big difference now as to what size of wheel I can cut. So I think what I'll do is, first of all, I've set that pretty well on the centre line of the lathe. This is 5 1/4 piece of wood in here, 5 1/4 inches diameter, and that would be the largest size I think that I'm going to be able to cut, because it touches on the top here unless I have a very big stick out. So yes, that is just possible. Ideally, what would be required to do large diameters would be to be able to have this offset to one side so that it didn't have this step in the way. So if this column sat on top of a plate that was sticking out to this side, then it could quite easily cope with 6 inches in diameter or more. But 5 1/4 inches is the biggest sort of size that would be reasonably easily be able to be cut. So if I take this to here, you can see this is one of the larger diameter cutters. That's why I put this on, just so that you can get an idea. And that's right at the top of the treble. So it would cope with something a little bit bigger, but not much. Cutter sizes vary quite a bit. This is the largest size of cutter that I've got. I have various sorts. That's a DP 16 cutter in comparison. So that would be easier to cut. Now I use that for cutting gear wheels. And this is a DP 24, slightly smaller still. And the clock wheel cutters are even smaller. When doing this, obviously the larger diameter you can put on the attachment, on the ER collet attachment, the better, because it would be more rigid. So I will actually cut some more spindles to put them on. So those are the issues, and I'm sure you can understand now why I had to make this much taller. And this locks up in the same way as it did before. That locks on there, and these two levers lock it here. So that's absolutely rigid there. I'm not at all sure. Certainly in wood it wouldn't be a problem. In brass it wouldn't be a problem cutting like that with that sort of degree of stick out. I don't like it, but there's really no choice. It's about 3 inches or so, 4 inches maybe. So is it worth making a plate to go on here so that this can be offset? That's really what it needs. Drilling into the front of the plate, absolutely no problem at all, and that can be done by going back to the previous arrangement of having the lower height, but there isn't really any need to change the height now it's done. It's exactly the same. It's unaffected by it. So what I have done here is I made this a bit longer because it was tended to foul the wheel here. So it'd be easy enough to go back to drilling into the face or drilling at an angle. I'll just take off the rising blocks and show you how easy that is to do. First of all, I have to take the screws out of here. Blocks out of the way. Just lock that down. Wind this up. And these two blocks lift out. Just have to move this up a bit. And that's the way in which they come out. Very straightforward. Perhaps just explain what I did to machine them. It was one piece of cast iron as a disc of the same diameter as here, and then I was faced with having to cut out the shape and drill the holes. So I drilled the holes first because they had to be accurately positioned, and I made sure that the drill was set up with it being absolutely plumb vertical, so that when I drilled these holes they came out and matched up with the holes at the bottom. And I drilled obviously through the holes at the top to mark the positions, and then drilled through, and three of them came out absolutely perfect. One was slightly off, but I managed to increase the drill size slightly to overcome that. And the rest of this was done by, first of all, attempting to do it on the mill, and I had a real problem. I set up the mill very carefully, so that you could see, and I milled the surface off here just to check it was aligned correctly, and the moment I started cutting a 1mm depth of cut, which is just here, the cutter grabbed and then turned the work, not in the chuck, but turned the whole of the chuck out, because of course it was wanting to turn clockwise rather than anti-clockwise, and unscrew the thread, which then jumped around and made a mess. So I had to think of another plan, and had to machine this piece. In the end, I did it by cutting it with my hacksaw, with a power hacksaw, the small one that I've got, and that worked okay. So effectively these pieces are cut from the side here. And the rest of it, getting it accurate, was just done by very careful filing and checking. So when this goes back together, these pins here help align everything, but it's not absolutely perfect. And to go back to the original, I've got shorter screws that I can fit in here and just merely drop the collar down, but as I said before, I don't think I'll be bothering doing that, because it's just as easy to leave it at the full height, and it's much more useful to have it at the full height. So what I have to do now is to drop this down, do it gently. And then all of these screws go into the original screw holes in the top. So the only thing I've done is to drill those two little thin rods, 4mm rods, to help locate. And unfortunately these tend to move just very, very slightly, so I've discovered the best way to do it is to just put these in very loosely, not absolutely tight in. Do that first, and then move this back up again, and help align the tends to just bind here slightly if they're not mating absolutely perfect. So you run this part way up and then tighten the screws there. That usually works fine. A little tighter at the top than I'd like. Just undo those again and tighten them up again. Just enough to be able to slacken that off to make the adjustment. There we go, that's perfect now. Sure those are done nice and tight. as I said before, that's one method of locking it, and that locks this thread, and these two push out the brass pins into the face of this and pulls the whole thing back tight up against the face on this side. So I'm well pleased with that. That's now as useful as I can get it. The only thing, as I say, is whether it's worth making the effort to fit an offset system, but I suppose I'm not unlikely to be cutting wheels much bigger than 5 inches. I don't think any of the Rivett wheels are bigger than 5. I've made no changes to the motor drive. That still screws on onto the back here as before. So that's the motor drive fitted. I haven't put the belt on, but you've seen that on before. That's the milling attachment, and worth having bought, well worth having bought, especially now I've managed to increase its usefulness. Now the chuck in it was an issue, and I can show you how I've now overcome that. This is the chuck that I had mounted on the milling machine, and you can see I fitted I can get it out, a thick washer inside here, and with a left hand thread screw it will screw through into the back plate of the rotary table, like that, so that this will have a left hand thread, this has a right hand thread, and that locks the two together so it can't be unscrewed. It's a nice simple arrangement, and these backing plates are available for Myford chucks as well as Boxford thread, which is what I've got. So I'm again pleased that I've managed to find a way of locking it. I've now come to the mill, and this is the interface plate that takes the chuck, and this is the thread that goes into the chuck, and on the back of here, unseen underneath here, is a spigot that sits in the Morse taper and holds this absolutely concentric, and then there are just the 2 screws here that go across. There's 4 slots in the table, and they have T-nuts on the underneath, and those are put in nice and tight, and they can't be taken out or taken out or put back in or tightened up once the chuck is on, which is a bit slightly annoying. Give it a little squirt of oil, because this will be together for quite a long while. The main problem is cleaning up the threads on the chuck. and it's well worth spending a good deal of time blowing out the compressed air, and then also mounting it on the lathe so that you can be sure that it's absolutely free. That's going on nicely. So I want to spin it on so it goes up against the shoulder and locks in. I don't want to bash this too hard, I'll just give it a tap with a dead blow hammer. So that's got the chuck spun on. Next job, I just open this up, the jaws up a little bit. There, that's it. So that sits on the little machined out portion in here. The one good thing about doing this is that it seals up the threads from getting any swarf in them, and there's bound to be swarf. Move this up a little bit. And this is a left-hand thread. Alright, now that's now tight. The only thing I have to remember now, whenever I want to take this apart, that's a left-hand nut, left-hand thread in there. I think perhaps I'll just mark it with something. So I've written left hand on there. So hopefully in the future when I take this apart it will be obvious to me. So that's one way of making this chuck so that it won't unspin when it's being machined, I did think that might be quite a good way of doing it on the lathe with a tube running through as a drawbar, but I had to think about that first. But anyway, at least I've got a chuck on here that won't come off in either direction, because it tightens up one way on one thread and tightens up the other way on the other thread. But I've done them both up reasonably tightly, but enough I think, and I don't want to overdo it because it might disturb the worm gear, and I haven't got the lock on the table, which I perhaps should have when I'm tightening up. I took that off when I was doing the works to the table, and I had it apart and I never put it back on again because I didn't think I'd use it.